Hello friends, in this lecture we will see planar milling, and for planar milling I have a this part, and I will show you how to create toolpath for planar milling, and this is a symmetrical object. So first of all I'm going to define this MCS mill, and my MCS mill center is here, and I'm going to define my workpiece. So this is the boundary and blank. See, this is the blank. Okay, here if I want I can use this part boundary as well, but I want to show you how to pattern toolpath, so that's why I'm using this bounding block. Okay, now specify tool, so I'm going to use 10 anvil. Okay, 10 is and length is 10, and here it is 50, and add one folder. I'm going to use from the library. See, here we have different type of tool holder. You can use any one of this, and the number is 1. Okay, now select create operation, and here in operation I'm using this planar milling. We use this planar milling to cut on about the fixed axis to a planar face. Okay, these all are operation for the planar face only, so I'm going to use this to roughing operation. So the tool is this workpiece and method is roughing. Okay, first of all a part boundary, so my part boundary is this, and tool side is outside, change it to inside so that it will cut inside this. Okay, add, my second boundary is this, tool is inside, and third one is this, and okay, and specify the floor, and we can specify only once this floor cannot be changed for all pocket, it must be same. So specify this floor to specify the depth of this pocket. Okay, the depth for all the pocket remains same, and diameter step over is 40%, and I'm going to use this depth of cut as 1. And here geometry, specify the blank, so my blank is this, tool side inside, add, second blank is this, add, third is this. Okay, okay, next tool axis. See here the tool axis is z axis, so tool will come from the z, so my z is here, and here it is cut order, change it to depth first, so first it will cut the depth, then it will shift to the another pocket. Okay, optimize or standard, so I'm going to use this standard and generate. See, first, okay, first, second and third. If I'm going to change this to optimize, generate. Okay, because we have limited pockets, that's why it is not affecting that much. And from the main, my depth of cut is 1, and it is still not showing this, and part depth, keep it 0 and generate it again. Why it is doing like this? Because we have specified the blank boundary, which is the bottom face, so I'm going to change this so that it will use hold the pocket. So my first is this blank boundary, second blank boundary is this, add, and third blank boundary is this. Okay, now generate this. Okay, and see what happening. It is cutting whole the boundary in a single cut. Okay, so from this part remove all this face and select the curve, and I'm going to use this first, add, second one, add, and the third one. Okay, the floor is specified. Now see, first, second, and third pocket. Okay, now I want only one pocket, so just remove the third boundary and this first boundary. I'm just keeping this one, and same I'm doing with the blank boundary. So from geometry, remove this and remove this. Only one pocket will cut. This is the pocket. Okay, now click OK. Now I want to make the copy of this toolpath. So click here and right click. Under this toolpath object we have this transform. Use this transform, and under transform we have rectangular array. You can use this rectangular array. So my reference point is this, my array point is also this. Okay, and 2 and the gap between these two is 76 and 76 both side, and see the preview. Okay, it is generating on. Now we have created 2 by 2, it means 4, 1 2 3 4, 4 instances there, but already we have done one operation we have already done. Okay, so I'm going to delete which is repeated. This one is repeated in the same pocket. This is the original one, this is the instance in the same pocket, so I'm going to delete this one. Just delete. Now 1 2 3 4. Let's see the verify of all of this, and speed, increase the speed, and let's see the second pocket, third pocket, and the outer pocket, this final one. So we can pattern it, we can transform this toolpath with the help of this transform. Okay, or delete this one, we can use mirror command, or we can use translate option to copy this. So this is the planar mill.